Hello viewers, welcome back to my channel. Hope you are doing great. If you haven't subscribed to my channel yet, please go ahead and subscribe. I have created bunch of playlists to cover various categories of the problems which involves primary data structures such as linked lists, trees, graphs, arrays and hash table. Also, I have created playlists to cover various programming paradigms such as dynamic programming, breadth first search, depth first search, divide and conquer, and so on. So please check them out. I have uploaded the code for this problem to the GitHub repository. You can get the link from the description below this video. Let's jump into today's problem. The problem is contiguous array. Given a binary array, find the maximum length of contiguous subarray with equal number of 0 and 1s. Right? So we are given with a binary array. So binary array will have only two numbers like 0 and 1. So we need to find a consecutive subarray where the count of ones is equal to the count of zeros. So if you look at the example 1, right? So 0 and 1. So there are only two elements. So that's why we will say, okay, number of zeros and number of ones are just 1, right? Number of zeros is 1, number of 1 is also 1. So that's why the contiguous subarray is 2, which is equal to the complete length of the given array. So in the example 2, 0, 1, 0. So either this can be the subarray where the zeros and ones are equal, and this also is a subarray where zeros and ones are equal. So what we are going to do for this is we will have a counter. When we see a 0, we will increment the counter. When we see a 1, we will decrement the counter, right? So based on that, we will form a map. So whenever we see a map with some counter, right? So we will have a start point and end point. So for a given counter, we will have a start point and end point. Based on that, we are going to, calculate the consecutive or contiguous array length. So let's try to get an example better than like example 1 and example 2. So here I have a array where the length is 9, so that it will be easy for us to look and understand the concept that we are going to dig in. So if you look at this array, right, the array length itself is 9. So but when you see the maximum length where the consecutive number of ones and zeros are same is 6. So if you see this one, what I am highlighting, so in that the number of zeros are 3 and ones is also 3, right? So we need to come up with an answer 6. So our strategy to come up with an answer is we will have a counter which will be initialized to 0 to start with, and while we go through the elements in the array, right, we frame the count. So when we see 0, we increment the counter. So counter is initially 0, okay, count is initially 0. So when we see 0, we increment. Let me write down, for 0 increment and for 1 decrement, right? So that is what we are going to do. So for 0 we increment, so the counter became 1, and when we see 1, we decrement the counter. So 0, 1 minus 1 becomes 0. When we see 1, we still decrement, minus 1. When we see 1, still decrement, minus 2. We saw 1, minus 1, 1 minus 2, 0 minus 1, 1 minus 2. So basically when we see 0, increment the counter, 1 decrement the counter. That's what we are going to do. So once we have this count array, right, so what we are going to do is we will come up with a map where we see the same count value, right? So the count value 1, when did we saw this, the index is 0, right? So for here the index is 0, and did we see 1 again anywhere? No, right? So the start and end value for 1 is 0, 0. So this is a map that we are going to create. So for count, this is a count, what is the start point and end point? So for the 1, the start point is 0 and end point is also 0. For 0, the start point is 1 and end point is also 1. We never saw 0 after this, right? We only saw -1 and -2's, right? So -1, when is the first time we saw? This is at index 2, 0, 1, 2, right? We saw at 2. And when is the last time that we saw? At index 8, right? At this point. So the total number of elements is 9. So they are ranging from 0 to 8. So we saw at 8. So 2, 8. Minus 2. When did we saw minus 2? 0, 1, 2, 3 at third index, right? And when did we see the last? 3, 4, 5, 6, 7. So this is actually 7, right? So did we see any other elements other than 1, 0, minus 1, minus 2? No. So we have only this in the map. So now what we are going to do is go through this map, okay? Go through this map and try to calculate the difference between start and end. So typically you do end minus start, okay? So the first one is 1, 0 minus 0 is 0. So the length is 0 for 1. For 0 also the length is 1 minus 1, 0. For minus 1 the length is 8 minus 2. So that is 6, right? And minus 2 the length is 4, right? So what is the maximum length that we observed here? 6. So 6 is our answer, which is what we want. So just to recap, right? There are 3 steps that we are doing here. So first step is to get the counter, right? Counter array. So what is the logic to do the counting? When we see 0, we increment. When we see 1, we decrement, right? So that's the first step. So once you have the counter array, we go through the counter array in conjunction with the given array and frame this map. So once you have this map, right? 1 start and end, 0 start and end, minus 1 start and all the elements in the count array you have starts and ends, right? That is the second step. And the third step is go through the map and calculate the difference between start and end, which will give you the length, right? So that will be the length, whatever the maximum length that you are going to see will be our answer. So this is a 3-step process. So we will be combining these 3 steps into possibly 2 steps, okay? We will be combining these 3 steps possibly into 2 steps. So what 3 steps were: coming up with a counter array, preparing a map, and going through the map and calculating the maximum length. So going through the count and preparing map, these 2 we will do in 1 step when we look at the code, and finally we go through the counts map basically, right, and come up with the maximum length. So let's go ahead and jump into the code for this particular problem, right? So since we have to keep track of the start and end for a given count, right, I have created a placeholder class to keep track of the start and end. So let's go ahead and look at the placeholder start first, okay? So it will have a start point and end point, right? So basically what we are going to keep track is a count. For a given count we need start and end, so we will have start and end. So this is just a placeholder class. So initialize the count to 0 and maximum length also will be initialized to 0. Dictionary. So we will have a map where we will keep the count and this node will have the start and end, just like this, right? We have a count and a start and end. So count will be represented by integer and node will have the start and end. So this is what the map that we are going to build for this, okay? And to start with, we will have a value 0, that means count is equal to 0, and we will initialize the count with -1 and -1. So it did not occur, that means, right? So to start with, we will say, okay, 0 did not occur at all, right? So it occurred only at -1 and -1 to start with, because count is initialized to 0. So these are all the initialization things. So this we added. So now we go through the array. So what is the array? The num dot length, right? So here for counter, we are adding a 1 when it is 0. We are decrementing a 1 when it is non-zero. So that means the same thing. When it is 0, we are incrementing the counter, right? When it is 0, we are incrementing. When it is 1, we are decrementing. So that's what is done by this step. So now, as I said, we are going to do the counting and creating the map in one single step. So this is what I meant. So right, so we have counted and preparing the map also here, right? So check if the map contains the count. If so, you just update the end. If it is not there, you add the start point and update the end. Start point is I, right? So whatever the I, the current location, and end we are updating to I. For example, 1, right? So it did not occur any time, so we added with 0, right, and -1. That is the initialization, and at the end is also initialized to I. So start and end are getting initialized and the map is getting created. So by the end of this for loop, we are done with counting array and creating the map also, right? So we have the map now. So once we have the map, what we are going to do is we go through the contents of the map now. So we leave the array as it is and then we go through the counts of the contents of the map. So now calculate the maximum length by subtracting the start and end value, right? So end minus start, because end will be always greater than start because we are starting from 0 to nums.length, right? So end will be always greater than start. So what we are going to do is end minus start is the value that we are going to get. So the difference between end and start. So that is end minus start. And we will compare with the maximum length that we have accumulated so far. If it is greater, we will update the maximum length. So finally, once we go through the map, right, we will just return the maximum length, right? So we have compressed 3-step approach into 2-step in the code where we are counting and building the map. So once we have the map available, we are going through the map and try to calculate the difference between start and end. So the problem itself is not too much tricky, but how you keep track of the count and their starting and end position is the question, right? So once you get the idea, then all the problem becomes pretty simple. So let's go ahead and try to look at the time complexity and space complexity for this particular problem, right? So how much time we need for this and how much space we need. So let's say n is the length of array, right? Length of the binary array, let's say. So how much time we need to process this is a question, right? So we are going through this entire length by one time, right? So we are starting at 0 and going through the nums.length. So we are doing the traversal of the entire array once here, right? So for that, since we are saying n is the length of the array, well, time complexity will be order of n plus. So we are going through the map once, right? So how many elements could be there in the map, right? How many elements could be there in the map? So in this particular example, even though the length of the array is 9, the count map has only 4. That means half of the elements have in the map, right? But for example, if you have something like this, right? So 0 0 0 0 0 0, right? So if this is array, so we will have to keep on incrementing. So 1 2 3 4 5 6 7 8, right? So we will have to keep on incrementing, and then start and end points we will be having the same. So 1 occurred at 1, 0 and 0, 2 occurred at 0 and 0, 3 occurred at 0 and 0. So that means in this particular case, the number of elements in the map will be equal to the number of elements in the array, right? So in the worst case, we will go through the map order of n times, right? So in the worst case, we will have to go through the map in the n times. So we will say order of n. So totally the time complexity will be order of 2n. Since big O notation, we will remove the constants from the notation, right? We will say the total complexity of time is order of n, right? So total time complexity for this particular problem is order of n, where n is the length of the binary array. So let's look at the space now. So are we using any extra space here? Are we using any extra space here? Yes. So how much space we are using is the question, right? So int count, this is a simple variable, right? And another variable we are using is a max length, that is also 0, right? max length is 0 initialized. So these are the variables. So we will say, okay, these will take constant amount of space. And map. So this map, as we said, map could have n number of elements in the map, right? That's what we said when we are calculating the time complexity, right? The worst case time for map is also going through the map is also n. So that means there could be n elements in the map, right? So we will say, for that sake, the space complexity is order of n, right? Space complexity is order of n. Are we using any more space? Yeah, that's it. We are using these couple of variables and the map. So the space complexity is order of n, and space time complexity is also order of n for this particular algorithm, right? So if you have any further questions, please post them in the comment section below this video. I will get back to you as soon as I can. I have posted the code to the GitHub repository in 2 languages, C# and Java. You can get the link in the description below this video. If you haven't subscribed to my channel yet, please go ahead and subscribe, and also share among your friends as much as you can. Please click on the bell icon so that you will be notified about all my future videos. Thank you for watching. I will be back with another problem very soon. Till then, stay safe. Goodbye.